Hello and welcome to Algebra 2, Lesson 76. In this lesson, we're going to learn about the circle. So at some point in your Algebra 2 course, you will begin talking about conic sections. So these include parabolas, circles, ellipses, and hyperbolas. Now we already discussed how to work with parabolas before. Now we're just going to tackle the subject of circles. So the first thing is, let's just get a brief definition going. So a circle is the set of all points in a plane that lie a fixed distance from the center. So the next part of that is to say that the fixed distance from the center to each point is known as the radius. This is something you want to write down because we're going to use it in a minute when we talk about the distance formula. So the fixed distance from the center, to each point on that circle is again known as the radius. Now, the first thing you're going to come across when you get into the topic of circles is going to be the equation of the circle. Now, this is given to you in standard form, otherwise known as center radius form, and it allows you to look at the equation and very quickly identify the key information. So I have here, we can use the distance formula to find the equation of a circle. So how do we go about doing that? Well, let's think about what the distance formula does for just a second. I want you to remember that the distance formula allows us to take 2 points on a coordinate plane and find the distance between them. So if I had two generic points, let's just say x sub 1, y sub 1, and x sub 2, y sub 2. Okay, these could be any 2 points. Well, the distance between them is given by this formula. The d, or the distance, equals, we would have the square root of, you have x sub 2 minus x sub 1, this quantity squared, then plus you'd have y sub 2 minus y sub 1, this quantity is squared. Now, how do we use this information to obtain the equation for a circle? Well, if I'm given the center of the circle, which is not actually on the circle, it's in the center, and I'm given the radius, what I can say is that the radius gives me a distance from the center to any point on that circle. So generically, I could say that the distance is 2. The distance is 2, and this equals the square root of, so let me just replace this point right here, this x sub 1, y sub 1, with a known point of 1, 3, and let's plug into the distance formula. So the distance between any point, instead of calling it x sub 2, y sub 2, I'm going to call it x, y. So any x, y point that you come up with, because again, we know that the distance between them would be equal to 2 because our radius is 2. So following this, x sub 2 minus x sub 1 squared. So x sub 2 now here I've replaced with x, so I would say x minus, for x sub 1 I replaced with 1. So x minus 1, that quantity squared, then plus, we would have y sub 2, which now I replaced with y, minus y sub 1, I replaced that with 3. So then this is squared. So far, it's not actually where we need it to be. We need to do one additional step, which is to square both sides. So if I square both sides, 2 squared is 4, and this equals, this cancels with this. So I'm just left with what is underneath the square root symbol, which is the quantity x minus 1 squared plus the quantity y minus 3 squared. Now, for the purposes of what you normally see, I'm just going to take this 4 that's over here on the left. I'm going to put equals 4 over here on the right, because this is how you're normally shown this equation. So this is your center radius form. This is your center radius form. And you might hear this called standard form for a circle. Those two can go back and forth interchangeably. But the key thing here is to understand that your center will be given by this guy and this guy. So as long as it's in the format of x minus something and y minus something, you just take whatever the number is here and here, and that's how you're going to find your center. So your center here is 1, 3. We already knew that because we were given that information. And the radius comes by taking this guy and taking the principal square root of it. So in other words, this right here represents the radius squared. So taking the principal square root gets me back to the radius. Take the square root of 4, I get back to 2. Now, some people will get a little confused and say, well, why don't you take the positive and the negative? The reason we don't say that the radius is also -2 is because the fact that a distance has to be non-negative, right? You can't say that, hey, I'm going to get in my car and drive -2 miles to work. You're either going to go 0 miles and not go anywhere, sit at your house, or you're going to go some positive amount, right? But you can't just go a negative amount of miles somewhere. All right, so here is the official formula, which you'll see in your textbook. So the center radius form, you have x minus some value h squared plus y minus some value k squared, and this equals the radius squared. So the center is h comma k, and the radius we find, again, by taking the principal square root of what we see here. So if I know my center and my radius, I can very quickly graph something. So to graph a circle, I start at the center, which is h comma k. I make a nice little clean point. Then I move by the amount of the radius. So up, down, left, and right. So you end up just making 4 nice clean points. And then you draw a smooth curve through the 4 points. So let's look at a few examples. These are things you would see in your textbook pretty much right away. So we want to identify the center and radius, then sketch the graph. So we have x plus 4, that quantity squared, plus we have y minus 3, that quantity squared, and this equals 4. So again, to match the format, we had x minus h, this quantity squared, then plus y minus k, this quantity squared. This equals the radius squared. Now, here's where you got to pay close attention. This is a minus sign here and a minus sign here. If it's not presented in that exact format, you have to make an adjustment to what you're looking at. This is a plus here. So what I would do is I would say, okay, I can write that as x minus a -4. So in other words, I can say this is x minus a -4. Now I've completely matched this format here. Then plus, this guy right here is fine. It's y minus some value. So I'm going to leave that alone. Y minus 3, that quantity squared. And then this guy right here, this 4, I would just take the principal square root of it. So the square root of 4 would be 2. So I'm just going to go ahead and write this as 2 squared, just to match everything up. So now I can just quickly look at the equation and pull the information out that I want. If I want the center, again, I match things up. H here, H here. K here, K here. So the center occurs at the point -4, that's my x value, and then +3, that's my y value. Then the radius, again, when I take the principal square root of 4, I get 2. That's why I wrote it as 2 squared. So my radius is 2. Now I can quickly graph this guy with this information. So I've already pre-drawn the circle, as you can see. The reason I did that, it's kind of hard to freehand draw a circle, especially if you're using a computer. A lot of people will graph this on their calculator, or if you freehand draw this on a piece of paper, you can kind of stick your wrist down and kind of rotate the page around and make a perfect circle. But if you really freehand draw it, it's kind of difficult to do. But again, if you wanted to do this, we're just going to do the exercise. The center is at -4, 3. So on the coordinate plane, I would go 4 units to the left and 3 units up. So that's why I have that point right there. That's your center. So this is the center. And I can just highlight that. And then after that, I'm going to make 4 points. I'm going to go up by the radius. So I'm going to go up by 2 units. So that's right here. That's why there's a point there. I'm going to go to the right by 2 units. I'm going to go down by 2 units. And I'm going to go to the left by 2 units. So that's where those 4 points came from. Now, once I've done that, I can just sketch the graph of the circle. Now, I'm going to try to do this to the best of my ability. And that's about as good as I can personally do. I know a lot of people are really good at drawing circles freehand, but personally, I am not good at it. So that's why I made a graph to kind of start off with. But it's just that easy. Just identify the center. Usually I just make a point. And then just move up, down, to the left, and to the right by the radius. Plot those points, and then draw a smooth curve to connect those 4 points. All right, let's take a look at another problem. So we have the quantity x minus 3 squared plus the quantity y plus 2 squared, and this equals 4. Again, match this up to, we have x minus h, that quantity squared, plus we have y minus k, that quantity squared. This equals the radius squared. So I can see that this is minus and this is minus. So my h here will be 3. So if I'm thinking about the center, the x-coordinate will be 3. Now for the y-coordinate, I have a plus here. So I've got to think about rewriting that. So if it's a plus, this is going to be minus a negative 2 to get it to match that format. So in other words, I can say this is y minus a negative 2, this quantity squared. And then we can see that k would be negative 2 here. So my y-coordinate would be negative 2. And then what about the radius? Again, you just take this guy here, and you take the principal square root. So I can really think about this instead of being 4. You can say this is 2 squared, right? So the radius is just 2. It's just this part right here, the base of the exponential expression you set up. So my radius is 2. All right, let's take this information and graph it. So again, the center occurs at 3, negative 2, and the radius is 2. So I go 3 units to the right and 2 units down. This is my center. So again, this is the center. And then I would make 4 points. So I'd use my radius, which is 2, to go up by 2 units, to go to the right by 2 units, to go down by 2 units, and go to the left by 2 units. And once I have those 4 points, again, I can draw a smooth curve, or I can attempt to. Not always going to be perfectly smooth, but let's try. All right. Again, that's about as good as I can personally do. All right, let's take a look at one more of these easy ones, and then I'll show you a harder scenario where the information is not given to you in this format, and so you have to do a little bit of extra work. So here we have x plus 2, that quantity squared, then plus we have the quantity y minus 3 squared, and this equals 9. So again, the format that we're looking at is x minus h, this quantity squared, plus we'd have y minus k, this quantity squared. This equals our radius squared. So what matches up and what doesn't? This is minus k, this is minus 3. So 3 here is k. The h here is not 2 because, again, I have this plus sign here. So I've got to account for the formula. If I see a plus sign, I can just cross that out and put minus a negative. So I know h is represented by negative 2. So for the center, we can say this occurs at the point negative 2, 3. Now for the radius, again, I could take 9, I could just write it as 3 squared, or I could take the principal square root of it and come up with 3. However you want to do that, but a lot of people like to just match the formula up exactly. So again, if you set this up as an exponential expression 3 squared, you know the radius is the base 3. So I'll put my radius here is equal to 3. So let's copy this. All right, so again, our center occurs at negative 2, 3. So I go 2 units to the left and 3 units up. So this is our center. This is our center. And then the radius is 3. So again, to make those 4 points, from the center, I'd go up by 1, 2, 3. I would go down by 1, 2, 3. I would go to the left by 1, 2, 3. And I would go to the right by 1, 2, 3. So very easy once I have that. Let me just change colors here, and I will, again, attempt to draw the circle. I'm just going to connect those 4 outer points with a smooth curve. All right, so there is our circle. All right, so in some cases, we are not given the equation of the circle in standard form. Again, otherwise known as center radius form. So when this occurs, we can obtain standard form by completing the square. So this is actually quite an easy process. If you remember solving quadratic equations by completing the square, it's kind of the same thing, but it's a lot easier. So essentially, all I'm going to do here, if I look at this first equation, we have x squared plus y squared minus 4x minus 4y minus 8 equals 0. The first thing I would do is group my x terms together and my y terms together, and I would take the constant and send it to the other side. So in other words, I would say this is x squared minus 4x. I would group those two together. And then plus, I would take the y terms, so y squared minus 4y, group those two together. And then I would add 8 to both sides of the equation. So this equals 8. Now, if you remember from, again, that lesson where we completed the square to solve quadratic equations, the steps would be to look at the coefficient on the first degree term. So in other words, the variable that is raised to the first power. You take that coefficient and you cut it in half, meaning you multiply it by a half, and then you square the result. This is what you're going to add to both sides of the equation to complete the square. So very, very easy to do this. So we have x squared minus 4x. To complete the square here, or again, get a perfect square trinomial, something I can factor into a binomial squared, I would take this coefficient right here, so it's negative 4. I would cut it in half, so I'd multiply it by a half, and then I would square it. Negative 4 times a half is negative 2. Negative 2 squared is 4. So I would add 4 here. Now, this gives me a perfect square trinomial. This would factor into x minus 2, that quantity squared. Here's the issue though. I added 4 to this side of the equation. So I can't just do that. I have to balance it by adding 4 to this side of the equation as well. As long as I do that, everything is okay. So then plus, we're going to do the same thing over here. So we have y squared minus 4y. Now, this coefficient here is the same as the coefficient here, right? I had a negative 4 here, and I have a negative 4 here. So without even doing the work of saying negative 4 times a half, that amount squared, which gives me 4, I can just look here and know that I would add 4 to this side over here. And again, doing that, I have to also add 4 over here, just to make sure it's balanced. So this is plus. We know this would factor into y minus 2, that quantity squared. Over here, 8 plus 4 is 12. 12 plus 4 is 16. So this equals 16. Now, you have this in center, radius form, or standard form, however you want to think about it. So we can look at, again, I can match this up with x minus h, that quantity squared, plus y minus k, that quantity squared, equals the radius squared. So in this case, it's basically perfect. The only thing I would do is I would write 16 as 4 squared to match up the h with 2, the k with 2, and the r with 4. So my center would occur at the point 2, 2, and my radius would be 4. Okay, very, very simple. Let's take this down to the coordinate plane and we'll graph this guy real quick. All right, so again, the center here is at 2, 2. So 2 units to the right and 2 units up. That puts me right there. Again, this is my center. And then the points we would generate here, the radius is 4. So I could go up 1, 2, 3, 4. There's a point. Down 1, 2, 3, 4. There's a point. To the right, 1, 2, 3, 4. There's a point. And then to the left, 1, 2, 3, 4. There's a point. And again, I just want to draw a smooth curve through the points. Just going to try to trace this guy that I've already pre-drawn. All right, let's take a look at one more problem here. So we have 2x squared plus 2y squared minus 12x plus 8y plus 24 equals 0. The first thing you would notice before you do anything here is that everything's divisible by 2. So if I went through and divided everything by 2, what would I get? This would be x squared plus this would be y squared. Then minus we'd have 6x plus we'd have 4y plus we'd have 12, and this equals 0 over 2 is 0. Now again, to complete the square, the first thing I'd want to do is I want to grab all my x terms and group those together, all my y terms and group those together, and I want to put the constant on the other side. So I would say this is x squared minus 6x, group those together. Then plus we'd have y squared plus 4y, group those together. And I would subtract 12 away from each side of the equation. So this equals negative 12. Okay, so now we're going to complete the square. Again, I'm going to choose something that takes that binomial there, makes it into a trinomial that can then be factored into a binomial squared. Again, perfect square trinomial means it's a binomial squared if we factored it. All right, so what do I need to do here? So this is x squared minus 6x. What's the missing part there? Again, I take the coefficient for the variable that's raised to the first power. In this case, that's going to be negative 6. I cut it in half. So I take negative 6 and I multiply it by a half, and then I square the result. Negative 6 times 1/2 is going to be negative 3. Then negative 3 squared would be 9. So I'm going to add 9 over here. But again, to make this legal, I've got to add 9 over here. So that part's done. We'll close the parentheses here. And then we can go ahead and factor, because we know this would factor into a binomial squared. This would factor into x minus 3, that quantity, squared. All right, so then plus, over here, we have y squared plus 4y, and then you have something that's missing here. So again, if I cut 4 in half, in other words, if I multiply 4 by a half, I'd get 2. Square 2, I'd get 4. So I'm going to add 4 over here. I'm going to add 4 over here. So this makes this into a binomial squared, which is going to be y plus 2, that quantity squared. Okay, then this equals negative 12 plus 9 is going to be negative 3. Negative 3 plus 4 is 1. So to put this into our format, I'm going to write this as x minus 3, that quantity squared. This has a minus sign here, so we're good to go. Then plus, over here I'm going to change this to minus a negative. So y minus a negative 2. So now we're good to go there. That's squared. And this equals, you could say this is 1 squared, right? Because 1 to any power is just going to give you 1. So I know the center is going to occur at the point 3 comma negative 2. And the radius will be equal to 1. That guy right there. So let's take this information down to the coordinate plane. All right, so the center occurs at 3 comma negative 2. So I will go 3 units to the right and 2 units down. So there's my center right there. So we'll say this is the center. And the radius is 1. So again, I could go from the center up 1. I could go to the right 1. Could go down 1. And I can go to the left 1. And then I just want to connect the points on the outside with a smooth curve. So don't worry too much about having a perfect graph. Again, the whole idea here is just to get the concept down, identify the center, identify the 4 points on the outside by using the radius, and sketch a graph through it, and you'll have a good idea of what the circle looks like.